So we now try to go through some simpler. If you have seen the syllabus module 1, I think you might or might not have seen. I will put it on the group. The module 1 is very simple. That is system of linear equations. So what we intend to take few examples and finish it quickly. Means we should not killing the time in very simple things. So we will take a very simple problem and I will make you to solve, and if you are able to solve, it is that there is no need for us to go have a exhaustive, what we can say, analysis of the module. It's very simple. So let us say that 3x1 plus 2x2 plus x3 is equal to 5. x1 plus 2 x2 plus 3x3 is equal to 8, and 2x1 plus 3x2 plus 4x3 is equal to 20. How will you solve? Be quick. What should be the method of solving? We need not come to the final answer. This is not the, what we can say, 11th, 12th class. How will you solve? What is the method? So without having any kind of means, this is called a system of linear equations, wherein there are multiple variables and linear combination of these multiple variables is some constant. So there are three variables x1, x2, x3, and linear combination. What is linear combination? Multiplying x1 by some real. Now again, real and imaginary, that is further debatable. Let us not be so specific. We say each variable is multiplied by a number and those are summed together. Is it clear? Linear combination, multiplying a variable by a number and adding such multiples, a linear combination. When it is linear, these variables exist in only first degree. Square होत नहीं, x1 square, square root of x2, x3 cube, then it is no longer a linear combination. Is it clear? Linear combination is of multiplying variables by different constants and summing such different multiples. So this is three simultaneous equations which you can solve by your own methods, right? Then, but the thing is that it takes much time. So is there a standard method by which I should be able to instantly find out the answer? What is that? Now, using the matrix theory which you have learnt in 11th, 12th and maybe M1, M2, M3, what we proceed, that is sufficient. So, matrix multiplication which you have learnt. So here, how many variables are there? 3 variables. How many equations are there? 3 equations. So, there will, listen, what I am telling, I am just, see the first module, and I have decided that we should stick to the contents first and then divert. So the first module I want to finish as quickly as possible because it is very simple. So 3 variables, 3 equations, there will be a 3 by 3 matrix. Additionally, there will be a column matrix of variables and a column matrix of the right hand side. So now this is 3 by 3. To make it simpler, I can use 2 by 2 also. So x1 plus x2 is equal to 5 and x1 minus x2 is equal to 3. Right? So how I write in standard form. This writing three equations can be reduced to writing it in matrix form. So the coefficients 1, 1, 1, minus 1, right? So x1 minus x2 is actually x1 plus, I think there is no need to write that much. So what I can say, this something into x1 plus something into x2. So this, you know, x1, x2. Something into x1 that comes here, something into that comes here, something into x1 that comes here, something into that comes here, right? And that is equal to 5, 3. Is it right? Yes. So a system of linear equations can be represented in a matrix form that is more compact and easier to handle, easier to represent, and easier to process further. Now how we can solve the system of linear equations with matrix method? And so you can solve, how you solve this? Even if matrix is not told to you, you add these two equations. So these two equations are in such a form that their mere addition eliminates one variable. So you get 2x1 equal to 8, so x1 equal to 4 and x2 equal to 1. That you get instantly. But that is not so easy with 3 variables. So we must find out. So in general, this is a matrix A, matrix X, and this is B. So this is called as AX equal to B form, right? AX equal to B. A is a matrix, X is also a column matrix, B is a column matrix. Now the question is, find X. Find X. How will you find? Using matrix logic. So what do we do? That there's no point in repeating the very simple things of matrix theory, that if I pre-multiply a column vector by an identity matrix of 3 by 3, if I so I into x is x, I into x is x, right? So it remains same. If I either pre-multiply or post-multiply matrix by its inverse, I get identity matrix, right? So if I pre-multiply on both sides by A inverse, what I get? X is equal to inverse. A inverse into A into X is equal to A inverse into B. A inverse into A is I, so I into X is X. So X is A inverse B. So finding out inverse, and then multiplying the column B, pre-multiplying column B by that inverse, you get the direct access. But finding inverse is not also so easy, but still at least there is standard method. Is it clear? Is the idea clear? So now in today's age, actually solving and spending unnecessary time in that is not required, because based on these calculations, no real-time operations should take place. We should get the idea, that's all. Now, you try to solve the following set of equations by matrix method. x1 plus 2x2 is equal to 5. 2x1 plus 4x2 is equal to 9. Be quick. Solve the system of linear equations given by matrix method. Tell me when you finish. So any answer? What happens? Can you solve? Anybody? These are whatever A you get, its determinant is 0. So it is non-invertible. What does it mean then? What is the answer? Not imaginary. Inconsistent. So a system of linear equations. A system of linear equation contains two things. Number one is number of variables and number two is number of equations. Right? Number of variables and number of equations. Then if number of variables are less than number of equations, if number of equations are less than number of variables, what will happen? If number of equations are less than number of variables, what will happen? It is having many solutions. Are you getting me? It's very simple, no rocket science. Only thing is that I am just what we can say, it's just warm up session. Number of equations less than number of variables. Does it mean that multiple solutions always? Again means again it is likely that suppose if I take a system wherein there are three variables, x1 plus x2 plus 2x3 is equal to 4 and 2x1 plus 2x2 plus 4x3 is equal to 7. What again we have here? Number of equations, number of variables are 3. Number of equations are 2. In that case also means number of equations when are less than number of variables, what we can say guaranteedly is there is no unique solution. No unique solution has got two things. What are? Ideal thing, a set of consistent equations equal to number of variables will lead to a unique solution. A set of linear equations, the number of equations is equal to number of variables and equations are consistent, it leads to a unique solution. But if somehow, what is the reverse of unique solution? युनिक सोल्युशन नाही म्हणजे काय असायला पाहिजे? either multiple solutions or no solutions. Is it right? So unique solution is possible if and only if number of equations equal to number of variables and these are consistent. If number of equations are less than number of variables, then unique solution is impossible. If these are inconsistent, then no solution, and in all other cases, multiple solutions. Right? In all other cases, multiple solutions. when number of equations are more than number of variables? When number of equations are more than number of variables, what does it mean? Now, let us say that we have two equations, say x1 plus x as taken 4, x1 minus x2 is equal to 1, or say 2, and what is it? What this you can call as? Multiple? No. Number of equations are more than number of variables. If it is so, this is one case, and in other case I will have same thing, and this to be 12. I will say third equation same, and I will make it 12. What is the difference between these two? When number of equations are more than number of variables, then if the system is having a unique solution, then those many number of equations are redundant which are in excess of number of variables. Here how many variables are there? 2 variables. How many equations? 3 equations. Let us take this case. So in that case, one equation is redundant. What does it mean? What is the meaning of redundant equation?
Why that was the same solution?
No. Redundant means it is not another equation. That equation itself is created by linear combination of, this is linear combination of variables. This is linear combination. 1 into x1 plus 1 into x2 is something. 1 into x1 plus minus 1 into x2 is some other thing. So linear combination of variables is some constant. Whereas this is linear combination of two equations. 2 into 1 plus 2 is this equation, right? So in a sense it is redundant. If it is 10, and if it is 12, then it is inconsistent. Number of when means when number of equations are more than number of unknowns. When number of equations are more than number of unknowns, in that case, if it is a system of consistent equations, then it contains few redundant equations, and if not, it is inconsistent. Is it clear? Absolutely, there should not be any issue of that. So now there are different ways. Inverse is one way, since it is mentioned in the syllabus. Now, whether you go for 2 by 2, will you go for inverse? So let us just as a warm up, and I think that we will be ending the first module this today itself. Solve 2 by 2 without using matrix operations, without using inverse. How will you do that? In 2 by 2 it is instant actually. But if it is 3 by 3, then it is somewhat. So rather than using, there is lower triangular matrix is to be made 0. So A we have got A11, A12, A21, A23, sorry, A22 into x1, x2, this is equal to B1, B2. So A11 x1 plus A12 x2 is B1. A21 x1 plus A22 x2 is B2. Right?
Yes.
Now, when one variable will be immediately known if A21 is 0. A21 is 0. So what you do? What operations you do? Row operations here are done here. So R2 from R2 A1 1 upon A1, sorry, how much times? A11 into something should be equal to A21. So R1, R2 minus something into R1 such that the resultant becomes 0. So rather than this variable form, we can make it like this. So the example which you considered, what was that? 1, 1, 1 minus 1, 1, 1, 1 minus 1. And this was 4, this was 1. 92. So how do we do that? R2 minus R1. What do we get? R2 minus R1 we get 1, 1, 0, 2, minus 2. Minus 2 is equal to x into x1, x2 is equal to 4 minus 2. Right? So minus 2x2 is equal to minus 2x2 equal to 2, x2 equal to 1. Is it right? So here you get instantly. Means rather than finding inverse, having row operations so as to make the lower triangular part, since it is 2 by 2, is only one value to do. Now we take another example. I think that it is very preliminary and everybody must be able to solve. x1 plus x2 plus x3 is equal to 6. x1 2x1 plus x2 plus 3x3 Now you solve this by using row operations. So what is the matrix now? So just, anybody got the answer? I have made you
R2 minus twice R1.
simple. What do we do? R2
Minus twice R1.
minus twice R1. So what we do, each time we don't write x1, x2, x3, we only write matrices. So R2 minus 2R1. So 1, 1, 1, 0, 0, minus 1, 1, 3, 2, 1. Then, and on this side, R2 minus 2R1 is 6, 1, 10. Now, R3 minus 3R1. So, I have deliberately chosen this to be simple. 1, 1, 1, 0 minus 1, 1, 0, minus 1, minus 2. And on this side, 6, 1, minus 8. So what next? Now it's very simple. This to be made 0. R3 plus R1. There are two ways now. Either way. This is also 0. So only one way. If we do it, then it will become 1. So R3 minus R2. R3 minus R2. So we get 1, 1, 1, 0 minus 1, 1, 0, 0, and minus 3, right? That is equal to 6, 1, minus 9, right? So what do we get? Minus, so from that it's very simple. Is it right? Is it okay? As I again repeat, it is a very simple and actually here the शिकवायची गरज नाही आहे. कशाला in a class, in a third year engineering classroom, something which याला काही वेळ दिला की म्हणजे काही वेळ दिल्यानंतर प्रत्येकाला आपोआप येईल ते सांगायची गरज नाही. बराच वेळ दिला तरी करणार नाही ह्याची चर्चा करावी लागते. So anyway, but we should finish now. Minus 3x3 is equal to minus 9. And the next is minus x2 plus x3 is equal to 1. And then x1 plus x2 plus x3 is equal to 6. So you get x3 as 3. The moment you put here minus x2 minus 3 minus x2 plus 3 is equal to 1. So minus x2 is equal to 1 minus 2 minus 2. So x3 is 3. Immediately x2 is 2 and x1 is. Is it clear? That by making lower triangular element 0. Is it clear now? So I think that I will give some assignments which you need to finish and upload in the classroom, Google Classroom. Sometime we may have, we are not ending, so you need not turn the notebook. Again, some absence is noted which I have taken very seriously, and I will give the instructions to absent students so that if they watch and write, put the notes in Google Classroom, then we may think of condoning the absence at a later stage. Prior to that now, so I think that the first module is Strang book is available in library also and in PDF form also. So you can refer that. That is, Strang is a classical reference from MIT professor. We also try to be more streamlined now, but wherever needed we will be adding up the things. So first module according to me is over. Nothing remains which is not possible to be understood on your own by solving the exercises. So next now we proceed for the introduction of what is called as, I think we switch here. So we begin with I think you know the name or I uttered vector space. Vector space. So vector space is you can get a feel of what is a vector space. You might have gone through strength lectures, or someone of you may have intuition, or somehow. What is vector space? What can be the definition of vector space? What is Marathi translation of vector space? What is Marathi name for vector? You are discussing about Marathi name? Okay. What is Marathi name for vector? दहावीला होता का नाही मराठी मीडियम वेक्टर काय म्हणतात त्याचे हां सगळे ऑल सीबीए ऑल इंग्लिश मीडियम सगळे ऑल नॉट a single person semi either not a single person who has studied science and maths in Marathi in the class. Is it so advanced? Or you? Not a single fellow. What about you? Same English. What about you? Last. Marathi कौन है? What is called as? पता नहीं. Adish and Sadish. So vector space, Sadish Avkash. So how? So this is it now. That is very childish things. What you learned is very simple and no time should be spent on that. So that first module we wound up. No doubt that it is required. There will be some examples in the examination which are very easy for you. That is there, but it is not worth to spend time on that in the classroom. So what is vector space, and what is vector space, and what is subspace? अच्छा लगा? We try to develop. आपण आधी डेफिनेशन सांगून वगैरे नाही तर एक्झाम्पल्स मधून डेफिनेशन काय असेल that you must be able to find it out. So the problem is that since we live in 3D world and we are not able to go beyond 3D, then I give some examples. Every plane each म्हणजे कुठलंही प्लेन घ्या ते ह्या स्पेस मध्ये असतंच. इज इट राईट? सो इफ स्पेस इज ए आता पुन्हा स्पेसला आणि पुन्हा वेक्टर स्पेस तेच येतं. व्हॉल्यूम म्हणूया आपण त्याला. व्हॉल्यूम म्हणू. लाईन, प्लेन अँड सॉलिड. So if volume we can say every plane lies in the volume. Am I right? Every plane lies in the volume because volume encompasses all. Now whether means when I limit myself to visualization and that context, I am not able to exactly interpret So the very statement that we need to verify whether a given plane lies in the given volume. I can listen every word. What is wrong in the question? I write two questions: line, plane and volume. किंवा लाईनच्या आधी काय? पॉइंट, लाइन, प्लेन and volume. I write some questions. Whether a given line lies in a given plane. Is it a meaningful question? Is it a meaningful question? Okay, now it's very much related to linear algebra, and I am sure that unless you have come across it, in a 3D space, write the equation of a line x, y, z, right? 3D space. So let us see. Write the equation of a line. म्हणजे आता बाकी सगळे वेक्टर स्पेस हे खूप पुढचं आहे, अगदी सोपं, हे यायलाच पाहिजे. आणि आता त्याला म्हणजे 10वीला मग सेमी आहे का याच्याशी डिपेंड नाही आहे आता. लक्षात आलं तुम्हाला? So let us forget about whether given line is there in given plane or not. Write an equation okay. आणि कुठलं any line you assume, any line you assume and write the equation. So आणखी सोपं करतो. Write equation of x axis in 3D Cartesian coordinate system. I J के वापरायचं नाहीये. X Y Z. काय? X लक्षात का? आणि हे येत नसेल तर y minus z equal to 0. says that y minus z equal to 0 is equation of x-axis. याचा अर्थ काय? हे x given equation is of a line which he claims, because the question is asked. आधी काय सांगितलं, क्वेश्चन अगदी सोपा केला होता, पण अगदी सोपं सुद्धा कदाचित येत नाही म्हणून थोडा अवघड करा. लक्षात आलं का? अगदी सोपं म्हणजे काय? यू टेक अ लाईन अँड फाइंड द इक्वेशन असं सांगितलं होतं. पण बऱ्याचदा काय होतं, क्वेश्चन्स डिफाईन करता येत नाही म्हणून कधी कधी स्टँडर्ड बरं प्रश्न विचारा, मग एक्स ॲक्सिस इक्वेशन काय. ही सेज दॅट y minus z equal to 0 or alternatively y equal to z. Is it equation of x axis? Claim. So you must be able to think logically. Claim y equal to y equal to z represents x axis. म्हणजे काय व्हायला पाहिजे? असं असेल तर आणि असंच असेल तर नेसेसरी अँड सफिशियंट कंडिशन. क्लेम y equal to z represents x axis म्हणजे काय? इट्स अ नेसेसरी कंडिशन. म्हणजे काय? x axis वरच्या कुठल्याही पॉइंटला y equal to z पाहिजे. आणि सफिशियंट कंडिशन म्हणजे काय? y equal to z असेल तर पण x असलाच पाहिजे. So is it correct? Or you want to withdraw the statement? You want to continue the claim? You are confused. Why necessary now? X, Y and x to y right-handed screw, z-axis. Is it right? So we can say x-axis, y-axis and z-axis. So what? Right. So what is x-axis? This is x-axis. So y equal to z. What does it mean? Y and z are equal. Means now question is whether y equal to z is a line, whether y equal to z is an equation of a line. You have studied in high school, equation of a line is y equal to mx plus c. Huh? Is it? So now I ask you again a question which you have learned earlier, whether y equal to mx plus c is equation of a line. Means now I refine the question, whether y equal to mx plus c alone represents a line. Y equal to mx plus c, what it is we have learned till now. Is it right? So m is the slope and c is this cross section. Right? Y equal to x is equation of what? mx plus c. M is 1, c is 0. So y equal to x, just like y equal to z I am talking, but since we are too much used to x, it becomes easy to visualize. So y equal to x is the equation of a line passing through origin at 45 degrees slope. So y equal to x is equation of what? I say y equal to x represents a plane. Am I right? There is 3D space, x, y, z coordinates. No equation. What will it mean? In 3D space, no equation. What it will cover? In a 3D space, when there are no equations, it will cover entire space, no conditions. Equation is a restriction, is a condition. It will cover entire volume. So in 3D terminology, 0 equations is entire volume. 3D terminology, 3 equations. X equal to 2, y equal to 3, z equal to 4. 2, 3, 4. What it is? X equal to 2, y equal to 3, z equal to 4. Means point P, 2, 3, 4. So 3D space, 0 equations, entire space. 3D space, 3 equations. 3D space, 3 degrees of freedom, everything is yours, entire volume. 3D space, 3 equations, no degree of freedom, fixed point. So number of degrees of freedom plus number of equations is equal to dimension of the space. So 3D space, 3 equations, point. 3D space, 0 equations, plane. Volume. आता राहिलं काय? 3, 3, 3, 0. आता राहिलं कुठलं? 3, 1, 3, 2. आता एवढं इतका सोपं आहे, यायलाच पाहिजे. Dimension, equations. 3D space, 3 equations, entity. Point. 3D space, it leads to degrees of freedom. Degrees of freedom, 3 dimensions, 3 equations, no freedom, 0. Sorry. No freedom, 0. 3D space, no equation, it is entire volume. Complete freedom. Now, 3 degrees, 3 dimensions, 2 equations, 1 equation. Degree of freedom 2, degree of freedom 1. So what this will be? Point to line to plane to volume. Right? असं असायला पाहिजे. Point to line. Point to plane. म्हणजे x, y, z मधलं एक इक्वेशन असेल तर ते काहीच इक्वेशन असेल तर एंटायर व्हॉल्यूम आला. एक इक्वेशन असेल तर काय आलं? प्लेन आलं. 2 इक्वेशन असतील तर काय आलं? आणि 3 इक्वेशन असतील तर काय आलं? Listen very careful now. Here, I'm winding up. 3 dimension space, no equation, entire volume. 3 dimension space, 1 equation, it is a plane. So y equal to x is a plane. Which plane? This plane. 3 dimension space, 2 equations. Y equal to x and z equal to 0. So intersection of these 2 planes is a line. Y equal to x is a line नाही. So y equal to x and z equal to 0. 2 equations make a line. Y equal to x and y equal to x plus 1. What these are? Y equal to x and y equal to x plus 1. What these two are? This is y equal to x. This is y equal to x plus 1. So 3 dimension space, 2 equations, if consistent, they represent the line which intersection of these 2 planes. If inconsistent, they represent different parallel planes. Y equal to x, y equal to x plus 1. 3 dimension space, 3 equations. If consistent, they represent a point. If not consistent, it may represent what it may represent? Two may be consistent, that may be one line. 2 planes, that one line, and another plane which is parallel to this. So again, one line and one plane, or three parallel planes. Is it right? I hope it is sufficient.